One of the hottest controversies in science is all about what happened 66 million years ago when dinosaurs were snuffed out of existence. It's been told that an asteroid more than 10 kilometers across slammed into the Yucatan Peninsula, putting an end to the dinosaurs' long reign. But the actual cause of death has been the center of a decades-long, raging controversy. Many scientists have argued for alternative theories to explain what brought on the dinosaurs' final days, including cosmic rays, an outbreak of disease, or, as we've previously reported, an inferno of blazing wildfires. But thanks to this recently published study in Science, we may have finally learned the truth behind what killed them. Aside from the asteroid, there's another competing theory involving massive volcanic eruptions that happened around the same time, leading to some confusion over which is the actual culprit. Over 500,000 cubic kilometers of lava welled up from the ground and spread across much of what is now India, a volume larger than 20 times all of the Great Lakes combined. This created enormous deposits of igneous rock, now known as the Deccan Traps. Along with the lava, the eruptions released carbon dioxide and other gases into the atmosphere, driving global temperature changes thought by some to have contributed to the extinction of 3/4 of the world's species at the end of the Cretaceous period. Vital clues to answering this prehistoric puzzle were found in sediment cores like the ones collected in 2012 by the research vessel JOIDES Resolution as part of the International Ocean Discovery Program. The cores may not have looked like much, but combined, they held more than 40 million years of ancient climate history, including a band of rock known as the KT or KPG boundary, which clearly shows the impact of the asteroid. On one side of the boundary, we find the Cretaceous period, where dinosaurs were busy living large. On the other, we find the Paleogene, where, poof, the dinosaur party had come to an abrupt end. Despite this, Team Volcano has argued that all 4 prior mass extinctions can also be explained by volcanic activity, and that asteroids have pummeled the planet before and life kept on moving. In 2019, researchers were finally able to use the deep sea sediment cores collected from the 2012 expedition to settle the argument. They modeled several scenarios, varying the timings of the Deccan Traps eruptions to see how the gases might have affected the climate. They compared the modeled temperature changes to the global temperature data reported in the cores to see if any of those scenarios lined up with the mass extinction better than the asteroid impact. In one of the hypothetical scenarios, researchers placed the bulk of the eruptions a couple 100,000 years before the KPG boundary. This model lined up with a temporary 2-degree rise in the temperature record, but since the temperature returned to normal before the asteroid impact, the Deccan Traps eruptions did not coincide with the extinction. In the second scenario, the eruptions were split evenly before and after the asteroid impact, but the volcanic disruptions that took place after the KPG boundary didn't significantly alter the climate, which was strange. Researchers found that a lack of global warming after a major burp of carbon dioxide could be explained by the extinction of tiny single-celled marine creatures called foraminifera, or forams. In a process called the carbon cycle, the ocean dissolves carbon dioxide from the atmosphere, where forams capture the carbon from it to build their shells. When forams die, they sink, and the carbon trapped in their shells is deposited on the ocean floor, moving it along to the next stage in the carbon cycle. But after the KPG boundary, the forams are nearly wiped out of existence. Without forams to move carbon, the oceans may have absorbed large amounts of volcanic carbon dioxide, limiting its effect on climate. This new research produced a definitive timeline that likely ends the decades-old argument that was often as heated as the volcanoes themselves. It also establishes that the Deccan Traps eruptions alone could not have caused the extinction, proving that it was the impact that wiped out the dinos. Other extinctions seem to have happened over hundreds of thousands of years, but what happened at the KPG boundary looks like it just took a few hundred. Regardless of whether we're talking about volcanoes or asteroids, both fill the air with carbon dioxide, ash, and noxious gases, just like humans are doing now by burning fossil fuels. Someday, a newly reigning species could be examining fossils of us. That's why getting a detailed picture of extinctions past with research like this is so important, to get to the core of the matter of life and death on Earth. Is there any other prehistoric science that you wish we were covering? Let us know over on Twitter and Instagram. We're @Seeker. Thanks for watching, and I'll see you next time.